metaprogramming. What is metaprogramming? Metaprogramming is kind of a little hard to define, but what it is pretty much writing programs that are capable of writing or manipulating other programs based on some kind of metadata. So we have metadata out there, and we have a program that goes, pretty much reads it, processes it, and does something with it. Changes itself or produces something else based on that, on the predefined metadata. It is not generative or automatic programming. It is not. It can be, but it is not all the time. It is supported by a lot of languages and platforms. It's something that is underused, something that is not well understood, kind of somehow like a black art. So unless you are somebody who's writing frameworks or doing that kind of work, you're not really going to feel the need to do any serious metaprogramming. You know as much, let me put it this way. Next slide. So certain concept that we're pretty much going to go over right now before is the concept of the meta language, which is simply the language in which the metaprogram is written in. So the language that goes and processes the metadata and then does something with it, that's the meta language. The object language is whatever pretty much comes out on the other side. So we say that we have reflexivity or reflection when the meta language and the object language are the same. When Java reads XML and produces Java based on that particular XML, or when Java pretty much goes and reads any other format or like any other form of metadata and does something with it, we say that that's pretty much like reflection when the language actually looks at itself. Next slide, please. So metaprogramming takes multiple forms in the wild. It could be as simple as exposing the internal of the runtime or the compiler as an API. If you have a language that pretty much gives you the capability to ask the runtime questions, like what type is this class, get information about the signatures of a method of a class, for example, that is a form of metaprogramming, or a language that allows you to actually control the compiler from within the language itself. Or it could be something like a language that would allow you to dynamically execute expressions containing code. So, and it could be just strings. Java or like Python, you give it a Python expression and it pretty much executes it to an extent. Or it does not have to be strings, it could be as well a series of method calls. And it could be something as sophisticated as a program transformation system. Meaning that there's a description right there that gets transformed to a target language. The compiler itself pretty much does that. You give it the Java source code and it translates it and then compiles it into this byte code or even binary, in certain, for other like languages that don't have an intermediate language. Yak takes grammar and produces C++ or C code containing the YY parse function. And Antler, great project, by the way. Usage in code. Why would we use metaprogramming? These are a couple of examples. There is certainly a lot more. But when you have a lot of static data that can be pretty much pre-computed or pre-generated at compile time, let's assume that depending on your environment, you have to create these huge pretty much lookup tables. You could either wait until the program pretty much starts and take a performance hit and do those computations over there, or you could pre-do that before, write code that would interact pretty much with the compiler or like ask the runtime itself about certain information and have that data pretty much prepared for your application before it starts. Or it could be, and this is probably the most useful features, to eliminate boilerplate code that cannot be abstracted in functions for dryness sake. Sometimes we have a lot of code that is scattered all over the place that we couldn't simply just go and modularize it and put it in like a function or like a static or like a utility and be able to pretty much like call it. You just can't do that. It's all over the place. As an example, aspects in AOP that deal with cross-cutting concerns and stuff. And we're going to go over that in a little bit. The concept of stereotypes in Spring. For those of you who are familiar with the Spring framework, you could simply just pretty much go and annotate a particular class as controller, and it would magically acquire controller behavior and know how to pretty much deal with HTTP and pretty much become a servlet. a simple POJO becoming a servlet, and this is because of the techniques of metaprogramming, instead of actually forcing the user to do all that kind of work. Next one. So the benefits in code, of course, you get like pretty much a performance gain if you do a lot of things like compile time versus like waiting until the runtime of the application. Gives you a great flexibility. And in terms of development time, it minimizes the lines of code to express a solution a lot. And I'm going to go back to the Spring example I mentioned before. Productivity gain, and it reduces the development time and efficiency. All these things are kind of the same thing in a way. They're all interrelated. So to go back to the model-driven engineering that we mentioned before, model engineering or like the philosophy is pretty much that there are a lot of artifacts that are a good candidate for auto generations. We all build applications. We all end up dealing with the exact same abstractions when we deal with the non-functional requirement anyways. You have security and you have logging, and the way the architecture of most enterprise applications does not really change. Most of them are pretty much in-tiered. And we end up with all of these abstractions, and we end up rediscovering pretty much the best approach over and over again. What MDE says is we should rely on code generation, rely on pretty much scaffolding as much as possible, and pretty much have the developer focus on the domain itself. You create your domain model, and you type a few commands, and a lot of stuff gets pretty much generated for you, or like all that boilerplate or the entire even structure of the application would get generated for you based on that. Think Ruby on Rails as well, Spring Boot on the Java space as well. So now that we've talked about what metadata is, we've talked about to an extent what metaprogramming is, let's talk about metaprogramming in Java. The first thing that I would like to talk about is Java annotations, and I'm assuming that a lot of you guys are familiar with it. It's been around since Java 1.5, and it's defined by the JSR 175. So before, what we used to do is pretty much would go and add the metadata as a part of JavaDoc in the comments, so like as an external XML using pretty much Xdoclets. And we built all these tools around it that would go to the comments, look for specific tokens, and pretty much extract that information. What JSR 175 introduced is these annotations that are more readable, closer to the code. They're statically typed, which is very nice. I mean, if you're a Java person, and can be pretty much retained until runtime. Because if you have stuff in comments, and then you compile your class, the comments are pretty much thrown away after the code is compiled, and they're not available for you in runtime. So annotations are. A lot of them, the JSR 175 defines some annotations that are a part of the JDK itself, like override and deprecate and suppress warning. If you're a user of Eclipse or any other IDEs, they'll pretty much like do that for you, and or like put like a little warning for you for those to be added. The JSR 250, common annotations for the Java platforms, defines a good set of them. Post construct as an example, at resource and deny all. Some of them are used for security. Post construct are more of a life management of the actual of the POJOs or beans. Next. So if you really want to take advantage of metaprogramming, is when you start writing your own annotations. Not very many people pretty much like do that. But and before we do that, I'm going to show you some code. I would like to go over certain annotations with you that will pretty much give you an idea of what we're talking about. So when we use the at target, that pretty much tells the JDK, or tells pretty much Java, that this particular annotation is pretty much used to annotate either a field or a method or a package or a parameter or whatever it is. So it's just an indication, tells them this annotation can only be used for this particular type. Next one. Add retention. This is pretty much the retention that we talked about. There are three different levels of retentions of the actual annotation itself. This is something that could be retained at the source level. That means when the code is compiled, it's gone. So it will be an equivalent to pretty much comments. Or class, something that is included in the class file, but the JVM doesn't really care about it. Or like at runtime, something that stays that information is pretty much kept while the code is live and running. At documented whether you want your annotation to pretty much show up in Java code, in Java doc or not. And lastly, inherited whether you want that particular annotation to be passed down the inheritance hierarchy. The last thing I'm going to talk about, and everything's going to make sense when I show you the code in a little bit, is the concept of attributes. These annotations have attributes, meaning if you just annotate something at ID, that's probably sufficient. But if you annotate something at table, you might want to be able to add extra information, add extra attribute like the name of the table and such. So there are certain restrictions around the values of attributes, like that they can only be primitives in Java, they can only be strings, they can only be enums, and they can only be one-dimensional arrays of the above. I think they allow class as well. And they may have default values, and the modifiers are not allowed. Next slide. So this is a piece of code. Can you guys see it okay? So this is pretty much an annotation. That's called pretty much at code review. What we want to do is pretty much want to build this tool that pretty much goes and scans our entire source code and detects and be able to tell us whether all the methods or all the classes within our source code was reviewed, went under review, or did go under a review or not. So we allow people to pretty much annotate their classes at code reviews and specify a list of authors and specify pretty much a creation date. And we just leave that. So the way this annotation is pretty much created is the second piece of the code right there. We use public at interface instead of public at class. We call it code review, and then we go and we define a set of attributes. Notice that the attribute authors is pretty much an array of strings. The creation date is a string, and it has a default as a string. You might want to ask me, why is it a string? Is because date and objects, regular objects, are not allowed to be attributes for annotations in Java, so we just put it as a string right there. The int version, the default version, is 1, and a status, which is pretty much the status of the review itself, whether it has been reviewed or not, and that's just pretty much a value of an enum. Yeah, notice that if you don't provide a default on the Java annotation, the compiler would actually force you to provide a value. So I only provided a list of authors and the creation date. I would be just fine with pretty much just creating the list of the authors, and everything would get a default. Java is not going to complain. But you have also the option of pretty much overriding the default value. Next. So MISC. You can also, in Java, you can also annotate packages. But to annotate packages in Java, what you have to do is pretty much create a file called package-info.java inside the package itself. And in there, you provide pretty much like a list of annotations of that particular package. One thing is we have the habit every time we want to create a Java file of pretty much just going and creating a class and passing package-info. That's not going to work because this is not an actual valid name for a class in Java. So make sure you create it as a file.java. Next. So metaprogramming in Java, meta annotation processing. I'm going to go over the different APIs that would allow you pretty much to do that. And this might be like a little boring for some of you, maybe a little bit more interesting. But the next section would be better. After we have this, after we constructed this meta model, we pretty much created all these like annotations, what to do with them. So at runtime, when your code is pretty much running, assuming that the annotations that you created to be processed have a retention, a runtime retention, we use pretty much simply JSR 175, which is a reflection. And what reflection is, it's pretty much reading the annotations, needing the annotations. This is pretty much like done in reference to the structure of the program. So what you do is you ask the question, this particular class, or the class named a certain way, or this particular field of a class, give me all the annotations that are pretty much associated with it. So this is done in reference to the structure of the code itself. JSR 175 pretty much defined the reflection API for this. There was a lot of work that is redundant and tedious. If you want to make your life easier, you can pretty much pick up the reflections library, which is a great library, and then a lot of that work is pretty much going to be abstracted from you. FastReflex is a very interesting library, which is a little more dynamic, a little more, not dynamic, a little more fluent, like a fluent library for annotation processing. Reflect and ISM is one of my favorite as well. Okay. So this is an example, real quick, a quick example. We have the annotation class, and we go my class, that class, give me all the annotation, and that returns an array of every annotation used in that particular class. And you pretty much go and iterate through it and verify whether it's an instance of that particular annotation, of my annotation that we were looking for when we do further processing. You can print out pretty much the value of the attribute by my annotation, that value, or do pretty much further processing with it. That's a little bit, that would be a little bit more interesting. Next one. So at build time, it's a different story. You don't have the JVM yet. I mean, your code is not on the JVM to just pretty much like ask it, give me the relations of this particular class. So what this one is called is mirror-based reflection, meaning that the annotations are pretty much accessible through a processor, where actually annotations are accessible through a processor API, and where reflective capabilities are encapsulated into intermediary objects called mirrors. So what this API does, it looks up your entire code, and it pretty much creates kind of mirrors that hold the metadata of your actual source code. In Java 5, this was not standardized, and we used to use this tool called apt, which is pretty much a standalone tool with the mirror API com.sun.mirror. So you use apt, and it goes over your code, and you can ask it questions about particular annotated elements. But in Java 6, fortunately, JSR 269 was introduced, which is the Pluggable Annotation Processor API. And it's kind of very interesting. JSR 269 leverages JSR 199, which is the Java compiler API, Java-C, that would allow you to pretty much programmatically invoke Java-C. It has the most important thing, an implementation of the service loader interface, and it would pretty much would allow us the capability to actually provide certain services for the Java-C compiler and have him pretty much execute them for us while at pretty much like build time. And that's what JSR 24 is. We're going to go in a little details of how this is done very soon here. So the Java 269 extends the Java-C as a plugin and allow us to write custom annotation processors. This is great because it provided seamless integration with the Java-C. All what Java-C does is just pretty much starts, find if there is an annotation processor registered to process a particular annotation, and then it plugs it into the compiler itself. It goes, I'm looking for @code review, and every time as it compiles the classes or as it goes through your source code, it finds @code review and it processes it in a certain way. So JSR 269, to drill in a little bit the details of this, is two parts. One of them is pretty much the act of writing the actual, the part that lets you write the actual annotation processors and lets you interact with the processing environment, which is defined in the package JavaX annotations processing, because you don't have system.out yet. I mean, system.out.println is something that exists in the runtime. I mean, it's literally a class of a part of the JDK that is available on runtime. So there are certain interactions that you would need with the environment, like getting feedback and taking care of errors and all of those things. And let's show you a code example in a little bit. And it has the part that models the Java programming language, which is pretty much JavaX lang model, the mirror API that we talked about. It has type declarations and types, and by the way, it kind of knows about generics. We all know that the problem with generics, one of the problems of generics in Java in runtime is type erasure. That means a list of integers or a list of strings is just list for the JVM itself for backwards compatibility reasons. The mirror API knows that this list is a list of strings that is different from like a list of integers. So if you were to do this in code, and I'll show you an example, a very short example, what you do is you provide an implementation of the processor interface. And meaning that you will provide some kind of implementation of a process method right there. And you configure your processor using certain annotations, supported annotation types, supported source, and then supported options. I think it would be best right now if I just go and show you a little bit of the code real quick. I'm not going to spend a lot of time in this. So can you guys see okay? Or should I make it a little, should I zoom in a little bit? Is this okay? So, yeah, so anyways, I think I just got some of the, can you guys see okay? That's fine? Okay. So what we have right here is we have an implementation, a class right there called forType processor. And by the way, forType is one of the annotation that I've written myself that extends an abstract processor right there. There are annotations out there that I'm only going to do this if the supported source version is pretty much like Java 6. And the supported annotation, and look right there, I provided the fully qualified name of the actual annotation that I'm trying to pretty much process. So the Java C pretty much goes and then has all these registered processors and then pretty much compares the fully qualified name. If it encounters the forType annotations, it pretty much executes the following code. The process method is right there, and I takes a set of type element and the actual environment itself, and that's pretty much like for the further processing. I am not going to drill down into the details of this particular code, but it's something that is pretty much straightforward. One thing that I would mention is pretty much this Boolean that is returned right here by the function itself. It only tells the Java C whether I'm done processing the forType and I should not mention it to other processor, or whether I should make it available for other, like, if you have 2 or 3, you can either like claim it back or like process it again, or pretty much or not. So going back to the slides, I gotta adjust the zoom level. We good? Okay. So registration. Right now, you went in, you provided this implementation. You're ready to register. So how can you tell the Java C about it? There are 2 different ways. The first one is simply pretty much using the command line. And you pass to Java C an option called processor, and pretty much you tell him this is the list of the processor classes that I pretty much provided, the forType processor in my case. There are other options, for example, that would enable and disable the discovery of this processor, if you wanna say that, or the use of this processor by the Java compiler itself. But the best way of doing it, the way I do it, is pretty much to leverage the Java service provider API JSR 2024 that I pretty much that we mentioned briefly, which pretty much would allow the compiler to auto discover and automatically pick up all the processors right there for your code. So these are some detail right there of how you could do it, but I might just show you. It would be like much easier to just show you the code. This is very simple. You could simply pretty much just go and create under the meta folder an inner folder pretty much called services, and you provide a file named with the actual interface that you want the Java C to pretty much discover. And in this case, since it's the JSR 269 processor, we actually named it Java X Annotation Processing Processor. So the compiler is going to go and look for everybody that pretty much provides an implementation for this interface throughout the class thing and pretty much use it somehow. And inside this file, you provide all the implementations that you want your compiler, the implementation of that class, that you want your compiler to pretty much consider or pretty much execute. And there's an array over there of implementations processing different annotations right there. You can pretty much like play with the order, and define like pretty much a position, and all that stuff is defined by the spec, pretty well defined by the spec itself. So a lot quicker than boring you with the entire slides, and pretty much this is what it is. Now that we learned all these APIs and we learned reflection, how we can ask the runtime about meta information associated with the annotated elements, we learned how to interact with the compiler itself and do that at compile time, what to do with all this information that we have access to and we can read. What to do with it is pretty much to construct a meta model. Let me go back. And what a meta model is pretty much when we take the metadata and we process it into something that can be accessed pretty much programmatically, as simple as pretty much a data object that is associated with like a field. I want my field classes, this is pretty much the information that is associated with the one field encapsulated in one DTO, or, I mean DTO is probably the wrong, in one POJO, to use like a right word. So this meta model could be something that is static or could be something that is dynamic. A meta model can be nothing, as simply tagging the annotated element as an ID. This is the ID of my class. Or could be something as complex that would provide metadata context of the annotated element itself. This being said, that the field can have 3 different annotations that would bring in attribute values with them, or it could be simply just pretty much a tag. This is an ID, or this is you know, a unique. This is supposed to a not null value for JSR 303. Let me go back. So what is a static meta model? To be very clear, I have a little code example, short code example for you for that. It's pretty much what we do is we create this one all-knowing God object that would encapsulate every possible metadata value that could be associated with the one annotated element. If you have an annotation right there that is 4 fields. You allow the target, whose target is like a field. You allow, what you do is like, you create this, this POJO that has all possible fields of all possible attributes or all possible bits of metadata that could be brought in by every annotation whose target is pretty much field. It'll become clear in a little bit. The advantage of this, and it's very simple. You know that this is a field, and you know that this is all the metadata that could ever be associated with it. It's statically typed, and with Java people, I mean mostly, we kind of favor that in a way. The disadvantages is pretty much you're going to have nulls all over. You go back to the next slide. So right here, we have certain fields, for example. We have a private long ID that is annotated with ID. It has like @generated, which is like another annotation that tells you how the value of that particular ID is generated. We have a column name associated with ID. The second one is a full name. It only have @column. The third one is email, and it's actually annotated with @unique, and @column has like an email right there. So we have 3 fields that have different combinations of metadata, of different combinations of annotations. So what our meta model is going to be, it's going to be a POJO that called possible metadata that's going to have a Boolean to indicate whether that particular annotated element is an ID or not, the name of it, whether it's unique, a Boolean again, or like the actual strategy, which has to do with the actual how the value of that particular element has been created. Now you look at this, use it for like the ID, and you see that all of these ones pretty much is ID has a value, and it has a name, and it has pretty much a type, but there is nothing, but it's pretty much like a default false for like uniqueness, which in the case of primitive types itself is kind of problematic, because it does not really make sense. I mean, there is no null for primitive types, and it's kind of false, which I don't know if I said this one right or not. But anyways, in the case of the second one, which is full name, all of those values over there are kind of irrelevant. The only one that we care about is the actual name itself. We look at the Boolean, they're both pretty much false, because that's pretty much the default, which does not really make any sense. But it's much easier to deal with, because we could just have getters and setters of this possible pretty much metadata. possible metadata object, and then pretty much ask the questions, give me the name, get name is unique, get me the type. So we take all these ones, and then we put it in a map of object that would map the actual field in the class to all possible pretty much metadata right there. And that's actual our static meta model. The next one is a lot more interesting, which is pretty much a dynamic meta model. And we kind of, I mean, certain people would call this this structure of the code the ravioli code, meaning that it's very small and loosely coupled. The code is constructed of very loosely coupled and small components, which is as simple as actually pretty much applying the simple decorator design pattern and kind of making the observation that all of these fields are kind of decorated with these annotations, right? You pretty much go that. So what you end up with is a dynamic model, which is pretty much just like a map of maps that is very flexible, but it's kind of complex. Complex in terms of processing the annotations itself and constructing the model, but it's correct and it's very flexible. I am not going to go down and explain and drill into what a decorator design pattern is or like how it's supposed to look like. But if you want to discuss that with me after the presentation, I'll be glad to. And they have actually code to show for this. We can go next. So now that we processed the annotations using these APIs, and we created them, we created this meta model, dynamic or static, it doesn't really matter. We would need some kind of validation. I mean, you can't just let people, especially if you're somebody that writes pretty much the framework, somebody who creates Hibernate, you can't expect people to just pretty much do things the right way and then highlight this with an example. So what validation is, in a nutshell, is pretty much ensuring the validity and the correctness of the semantics of metadata, because metadata brings in semantics. It tells you that this is a column. It tells you that this is an ID. It tells you that this is a table. And there are certain things like in a table you could only have like one ID. For your particular framework, if you don't, that's what you want. That's your pretty much choice. And unfortunately, compliance with these additional consistency constraints are outside the Java language spec. The only thing that is enforced by the compiler itself is at target. Is when you create your annotation, you say that I want this annotation to be for methods to be only allowed for fields, to be only allowed for classes. Next. So assuming that you're writing, for example, JSR 3.18, which is the enterprise Java beans, you woke up this morning and you felt very well, and you want, all right, I'm tired of these guys, I want to create my own implementation. So in the spec, it says that a bean, or like a POJO, can be both annotated as stateful and stateless. This is completely allowed, by the way, and compiler is not going to complain. But it does not really make any sense. You can't be both stateful and stateless at the same time. And if you're the one creating this framework or providing this implementation, you should have a problem with this and say this is not pretty much allowed, mostly in runtime. So this is anything but simple. Constraint satisfaction problem is very hard. I mean, you can go and read up on it online. There are a bunch of algorithms and solutions for it if you are interested, but these are pretty much out of the scope of this presentation. So, but it's not really that bad. I mean, because you're the one who creates those annotations. You suppose that you created 10 of them. And you can pretty much just sit down and have some kind of very simplistic algorithm that is like conditional. That would pretty much define certain rules, a certain logic that would answer the question whether this is valid or not. Just say if you process a particular field and it has stateful and it has stateless at the same time, throw an exception and say that this is not allowed. As simple as that. Go back. So this is pretty much the imperative way, Java. But what you end up with is a jungle of if statements. Crazy and unmaintainables, and you're just going to end up shooting yourself in the head. I'm not promoting that by any means. So, or you could solve these things in a in the logical way. That means using a logic programming language, where actually semantics are actually represented in a way that is declarative as predicates, and we procedurally interpret query pretty much resolutions. What you do in Prolog, for example, is pretty much go and you state, these are the rules, these are pretty much the fact, and you ask Prolog itself a query, and you're pretty much going to have valid or like invalid. This is a good way. So if you are on Java, there are different implementation of the Prolog interpreter in Java. There is a toProlog, there is JLog, and there is also an interface to sweep Prolog if a Prolog happened to be installed in the actual machine, which is pretty much just a JNI interface. It's great, but you're going to have to learn Prolog. If you're not familiar with it, you don't have the time for that, it kind of sucks. It's a lot of fun though. Or if you happen to be familiar with Clojure, which is a very nice language, is this Byte, you could, that runs on the JVM as well. You could use core.logic, which pretty much support logic and constraint programming. And it's like a very nice API actually will allow you to do that easily. There are other options for you that you could explore. One of them is the Prova rule language. It's open source and it's out there. Mercury as well. It's like a logical programming kind of type of language. And all of these ones run on the JVM. So they are very nice. They're actually pretty well documented in the case of Prova. Next. But there is another option. Another option is pretty much to use rules engines. That's what rules engines are for. So probably one of the most popular ones, the Rules Expert by JBoss, which is pretty much a highly performance and optimized rules engine. And it would allow your rules to redefine them in Mevel, which is just an expression language or XML. Not that hard at all. A lot of you are pretty much like familiar with it, dealing with all these expression languages and JSPs and all that. And it integrates very nicely with Java collaborative POJOs. It's pretty much a library, a job file, that you pretty much include in your project. You include that dependency. You define these rules in a particular file, and you pretty much take your Metamodel, and then you validate it against those particular rules, and you get pretty much feedback from the engine as actual Java objects, which is very nice. So check out Rules Expert. Now that we processed this we have this metadata in some format, we processed it, we constructed a metamodel, we validated that metamodel, we made sure that it's, the semantics are actually correct, what to do with it. I mean, you can just have the data just sit there. So one of the options is pretty much do some kind of transformations to the actual code itself, or like create new classes or like new bytecode. Like modify the abstract, rewrite the abstract syntax tree by actually changing the structure of your actual code. So you could say, for example, for all the methods that are annotated with add change, if statements to change if to switch, you want to go down the AST tree, and every time you find an if statement, you would change it to a switch statement, because you just hate if statements for some reason. You prefer the switched, or for some reason in some other universe, they happen to perform better. It can be your code, it could be somebody else's pretty much code. So you say, every time you see this particular annotation, please change all the if statements and turn them into switch statements. Or you could be adding or removing pretty much behavior, right? So automatic generation of cookie cutter code, right? So when Spring stereotypes a particular POJO at controller, right? At runtime, they would go and pretty much take that particular POJO and then have it inherit another class, which pretty much brings in the behavior of the controller itself and knows about servlets and knows about all that kind of stuff. Add methods, remove methods, you can do whatever you want with it. So you can end up creating a complex class hierarchy. Or based on that one annotated class, you want to create different things. In the case of the active record for the Ruby on Rails people, you define this one model, and based on that model, they look at it and they create a repository or pretty much a DAO that knows exactly how to persist that and pretty much read it from like a relational database based on some kind of configuration, based on the convention of the actual object itself and the configuration in the YAML file of what database that you actually had defined for your actual application. There are a lot of bytecode manipulation libraries. I'm going to mention a few. ASM, it's very small, fast, very low level. You need to know bytecode opcodes for the Java pretty much bytecode to actually understand this, which is a really good practice. But it requires a good understanding of the language spec itself as well. But it's very well documented. I mean, ASM is king. GClib, this is something that came as a response of the fact that not everybody wants to go and learn Java assembly. Nobody likes that. And they built like this abstraction on top of it. It's it performs really well, but it has some issues with when you start dealing with like signed jobs and everything. This library was used by Hibernate, but they dropped it in favor of Java Assist for lack of support and active development. Java Assist, which is the last one I would like to mention. I love this library a lot. It's very easy to use. It works well with signed jar. It has very good documentation. Has an excellent Java doc, and it was the one that pretty much was adopted by Hibernate. But it's a little slower than GClib. It's not that. I mean, for me or like for the problems that I was trying to solve, it didn't make that much of a difference. It's not really slow. But it allows you to pretty much just literally go and then construct your code in strings and then pass it to the ASM library, would actually create the equivalent code and then pretty much load it on the JVM. Use the class loader and load it to the JVM as live code as you do that. So, or you could, other than transforming, doing all these transformation and code generation, you could pretty much just do simple interpretations. One of the example of interpretations is pretty much just mapping one object to another one based on the metamodel itself. An example of this being done is Dozer, which is pretty much this library that takes one Java class and then copies it into another one, or maps it into another one. There are two different classes, but takes this one and copies the values on another one based on metadata right there, because a lot of the times, the fields are not named the same way. So you have this metamodel right there that tells you that field name, first name, camel cased, maps to a field called first name, Hungarian notation, kind of, whatever it is. You can do whatever you want. ORM frameworks as well. And it's pretty much this way. Now, a mapper would pretty much, you'll have like your POJO, your class, and you have the metadata associated with that class. Whether you chose to express it as Java annotations in the class itself, or whether you chose to express it externally as XML or JSON or wherever you want, you process it into a metamodel, and you have that data sitting there, right? The minute you have an instance of the POJO itself, that means that you don't only have the fields, you have the fields and their values, right? A mapper will take that information, all right, and create a new instance of whatever you're trying to pretty much interpret the object as. In the case of the object relational frameworks, every instance of the objects maps, for example, to a row. And I'm using this, it could be more than that, or multiple rows across different tables, but a row, for example. So we take the POJO, read the metamodel, interpret it a certain way, take the values and create a new instance, of the row class, which is a part of the persistent model. A very nice abstraction. So your code that interacts with the database does not know anything about your POJOs, has nothing to do about your employee class. All it knows that every time I get an instance row of this particular table, I pretty much go and save it to TBL employees. So, and that's what Hibernate does for you. Next. So the next thing that, other than transformation and interpretation, is dealing with these cross-cutting concerns. And what OOP pretty much creates is this hierarchical object model by nature. This thing inherits from this thing, and this thing implements this thing. But we have certain things that are not necessarily a part of the application logic. Certain things that you couldn't modularize anywhere because they show all over the place. Login, for example, transactions, security. You'll end up, if you don't use AOP, with login statements all over the place. You log in this class, and you log in this class, and you log here, and you log here when you have an exception. And you have all this code all over, and you couldn't really do anything with it. So what aspect-oriented programming is pretty much does, what it does is pretty much it allows you to say things like, if a method of a particular class through an exception, do this log statement. Or if an object of this particular class or an object within this package, of a class within this package is created, log this statement. So what you do is like, you remove all those cost-cutting concerns and you modularize them in these advices of these like aspects. And your code is highly cohesive and highly maintainable. You look at the employee DAO and it only does CRUD operations for employees. You look at some kind of service or your translation service and it only has translation code that actually carries the actual translation, no login, no security, nothing like that. But a lot of frameworks like AspectJ would provide that for you out of the box. You can choose to pretty much do that and just tag these point cuts and these annotated elements in the code yourself and say that every time you encounter @loggable, you pretty much log after like a successful execution. And you would do what is called in the AOP word code weaving at compile time or like at runtime using dynamic proxies. So as you compile, every time you see this annotation, you insert this statement here and you insert this statement here, which is pretty much the login statement. Next. There you could pretty much do instrumentation. There are very few libraries that actually do very good instrumentation out there. The one that I saw was from Yammer, I think. It's worthy of checking out. That defines a bunch of annotations that lets you say, time this method and time that method and such. But which would allow you to pretty much monitor and measure performance, do diagnostics and trace info. Things that are allowed by metaprogramming as well is pretty much inversion of control or dependency injection that the Spring framework is pretty much known for. When you say @inject, the runtime actually goes read off your meta data and pretty much injects the correct implementation of the interfaces in your POJOs. Next. So we go through all of this stuff right now, all of this mess. You got to do validation. You got to use rule engines for validations. You could use Prolog, annotation processing, this API and that API, and it's just tedious work. And me as a developer do not want to have to pretty much do that, reinvent the wheel each time. So how this project pretty much started is I was pretty much assigned to write a framework that looks very much like Hibernate that runs on top of HBase. And HBase is a NoSQL database. So I wrote the first one and did the whole thing. And at the end, when I thought that everything was pretty much done, I discovered that I had no validation that people were using are going to be using my library pretty much the wrong way. So I said, it's fine. Let me start doing a bunch of if statements. And it was hell. So what the presentation is pretty much what I went through trying to pretty much build this framework. And it was probably the third one, or maybe the most complex ones I built using metaprogramming techniques. I created this project pretty much called Project Averroes. All Project Averroes gives you everything out of the box. This is still a work in progress. I still need a lot of help with it. It's just a GitHub project right now. It's not done by any means. It's not even 0.1, but it works to an extent. But what this thing does is pretty much would give you the ability, in a nutshell, a metaprogramming framework. It gives you the ability to pretty much auto-discover all these annotations within a particular package. It does annotation processing for you in a dynamic model. It pretty much constructs that for you, and it does validation. And what I sat there and what would be the best way for me to allow people to pretty much express the semantics of their meta model easily and in a very nice and simplistic way. And it was annotations. Annotations or annotations. That was the simplest way that I could have came up with. So I created a set of annotations. And you might think about it as metadata. So, and there's a set of them right here, accompanied with at least one for type annotated with for type including. I'm going to use one of them and give you an example and show you some code. If you are writing Hibernate, for example, and you create an annotation called @table that was supposed to map to an actual table in your data store, you want to ensure that there's always an ID, that there's always a field within the type class called ID. So when you define your annotation, you define the retention type and everything, you would say for type including ID. And the framework would actually go create the rules for you and kind of go over your meta model and make sure that that's actually accurate. Not accompanied with is another one. This is the GitHub project. It's nowhere near done. Probably going to be doing more work with it around this thing in the next few months. But let me show you an example of how this thing works. So what I am a big fan of one-liners. So I want you to pretty much do this and say Averroes, new Averroes data.notations, which is pretty much annotations, which is pretty much the package that contains all your annotations. You go and define 20 of them, you just point my Averroes to that particular package. And I want you to say construct meta model for, and you give me a class for employee. That's it. I construct the meta model dynamically, I do the validation for you, and I pretty much just give you, here is your metadata, and here is a very nice interface for you that you can pretty much access at runtime. I will show you an example of this class. Can you guys see it really well? Is everybody fine? So we have the class that we're trying to construct, that you created, is this one. It's an employee class, and it has a bunch of annotations. It has an ID, it has a simple value, a column, and all of these things. Right? And it's like a table TBL employees. So those annotations are yours. They're something that you created. So we're going to take one as an example. We're going to take, for example, the table annotation. You're the one who writes Hibernate. You created @table, for example. All right? The way you're going to do it in Java is went over JSR 175 is we did public @interface table, and it has one attribute, which is pretty much the name of the table. We do @target. You can only have classes, annotate classes with that. You retain this thing until pretty much runtime. But I have two annotations that are part of Averroes, which is the framework that I provide. And the first one says that for type included value ID that class. So this type must include something that's pretty much annotated with that ID. And the second one is like not accompanied with embeddable. If you're familiar with Hibernate, there is the concept of an embeddable POJO and a table. So every class, every POJO, every entity maps to a table, but it can have nested entities, and they're just pretty much called embeddable. So it makes sense for an actual entity and an embeddable not to be the same, because it just does not make sense that way. You embed something in an entity, and that one's the embeddable, and this one is the table as well. So, and they have those rules around this particular annotation. I have other ones. I can show you, maybe I should show you all the annotations that I defined. This is the test project that pretty much include that one. I have, for example, column, right? And I have a rule that a column should not be accompanied with ID. You annotate something, a field called ID, you don't annotate it as column. It's as simple as that. And so forth. A bunch of them right here, right? Simple value, for example, is a little more complex. It's like not accompanied with composite values. You could either be simple or you could be pretty much composite, right? So enough of this, And let's go back to, let's get rid of this. Let's go back to the actual main code. Let's go to main, and I'm going to do this. So this framework pretty much does not only take classes right here, does not construct meta models for like a class only. It constructs meta models, in fact, for anything in Java that could be annotated, any annotated element. So right there, what I have is I pretty much got a field of the employee class called ID, a declared field called ID, which is this guy right here. All right? So what I'm going to do is I'm going to tell the framework to construct the meta model for ID. I'm going to run this code. I hope it runs. You know how it goes in. And I get pretty much this information. It just sits out, printed it out for you just to see it. But it says that this guy is a field. The property navigational path for it is pretty much ID. And it gives us the actual field itself. This guy is annotated with an ID, a simple value, right, and with an ID. And it gives whose data is. See that? It extracted the type, which is pretty much provided. It extracted. Yeah, it's pretty much said that it was annotated with this interface called pretty much ID and other information. I mean, this is probably like a. Let's pick another example. This one is not as friendly as I thought it would be, and let's just pick and say last name, for example. And the information that we were supposed to pretty much get from like last name is like family, HR, and then qualifier is first name for an ID called first name for this particular field. And we just say, give me the first name minimum. And there it is. It says that this guy was annotated with column, and this is the meta information that is associated with the actual column itself. I can assure you that this is not just reading off the actual, simply reading off that particular annotation, displaying it that way. It's actually in a dynamic data structure that was pretty much printed that way right there. So there is, and this is actually the next piece that I'm hoping to work on, is pretty much to provide a programmatic interface that would allow you easily to pretty much extract and say, for this particular element, what is the value for family, or what are the values that are like available, and things of that sort. But what we want to do is want to test out like the hard piece, which is pretty much annotations, and break this guy. So I'm going to go to this first name guy and annotate it as ID. Notice that I have two problems right there. The first problem is that I have two IDs that are within the employee one, and something that I didn't allow is pretty much to annotate the same thing with ID and column at the same time, and I go and pretty much run my, my code, and I get an error, right? The first one is it says that the element private Java string and first name cannot be annotated with both at column and any other annotation. And it gives me, for example, the one with the problem, which is pretty much ID. The second one is the element string, whatever it is, employee, annotated with ID must be of type byte. That's one of my rules as well that I didn't tell you about. I change the ID to long, right? I change all the IDs to long, and I change all my IDs to long, and I run this, and I get pretty much like feedback. Hold on. Oh. Yeah, I'm good. Didn't break. Thought it broke for a second. And I get the metadata for like ID, and I run it. I'm expecting it to say, you're not allowed to use anything other than byte for that particular. You're not allowed to annotate anything other than byte for the annotation ID. at ID. And then you can pass it the entire class. We're just going to do that for fun. Let me fix my my Byte thing deal here, so everything would pass, and then we're just going to run the entire thing, and there you go. It goes in my class, extract all the information, all the metadata associated with the class itself, and the children of that particular, the nested annotated element of that particular element right there. How this is pretty much done, if you're curious and you would like to talk to me about it, the project is in GitHub as well, is this right here, this data structure. Everything that is blue is pretty much decorator patterns that would pretty much go through all your classes and goes and build that meta model dynamically for you, right? The second part right here is, the red part is what does actually the actual annotation processing and creates this blue model. The green parts is pretty much what gets auto-generated for you, because when I go through the package and I look at all your annotations, I read them off, I read off all the metadata that is associated with them. I go and pretty much prepare a set of classes for you, and complete the decorator design pattern for you. Otherwise, you're going to have to go and provide an implementation here, an implementation here, an implementation here for every one of your annotations. If you want to process them, if you want to create this very nice dynamic data model, you don't have to do that, because I do that for you. I use this bytecode manipulation libraries to actually go and complete those data structures, and they pretty much call them a runtime, right? One thing that is pretty much important is the concept of pretty much validation, right there. I spoke to you briefly, guys, about rules. I dynamically create those rules. So I go, for example, in your column annotation right here, and you told me that you should never allow an add column to be pretty much at ID. What's happening in the background right there is I have pretty much a rules rule template for not accompanied with that define all these rules. This is pretty much just like a template. And I go at compile time, discover all of those classes right there, and create these rules, this rule of not accompanied with, for every single one of your annotations that you provided. This is something that, if you want to do things the right way and nicely, you're going to have pretty much to do yourself. And at the end, we end up with, let me see if actually, if that file actually came out before I tell you anything. Let's see if it's in the target. No, it's not there. So you end up with pretty much this huge rule files that I actually validate against every time you pass me like a particular entity, or every time you pass me a class. So you get all this stuff for free. I'm hoping that this is going to materialize to something that a lot of people use. I went down the source code of big libraries like Hibernate, different implementations of JPA, to kind of see how they actually go and construct this meta model. And I was very much interested in the actual fact of validating that semantic model, the meta model that they ended up with semantically, and most of them was pretty much a bunch of if statements that they pretty much have to maintain. But this is a framework, and that's the hard part about being a framework. You're too generic, and you should pretty much be ready for people to throw anything at you. Thank you very much for your time.